We will see the classification of third generation cephalosporin. So what are third generation cephalosporins? So these are cephalosporin which have less activity than first generation cephalosporin against gram positive. Means they have less activity against gram positive as compared to first generation and second generation cephalosporin, but they have much improved and expanded spectrum of activity against gram negative bacterium. Means their activity is much improved against the gram negative organism, but still they are not clinically effective against the Pseudomonas aeruginosa. Still they are not effective against this Pseudomonas aeruginosa, and they have high beta lactamase resistance due to the acyl amino group. The acyl amino group which is present over here, we will see later on. So due to this acyl amino group, they have high beta lactamase resistance. So now we will see the example. The first cephalosporin which comes under this third generation cephalosporin is, example first is cefotaxime. You have heard the name of this antibiotic, cefotaxime. Very famous and very useful nowadays, cefotaxime. So what is the structure of this cefotaxime? So actually cefotaxime have no changes at this position, CH2O, CO, CH3. This is what, as previously we have discussed, acetyl oxymethyl or acetoxymethyl group. Now the changes happen at this position. Over here there is a carbon, and this carbon is linked to double bond with a nitrogen, and on this nitrogen a methoxy group is there. Now this carbon is again fused with thiazole nucleus. How? This is your sulfur thia, and this is your nitrogen azole, and this have two double bond over here, and one more functionality is there. You have to memorize this functionality very importantly. Amine group is there, NH2. So this is the structure of your cefotaxime. So now later on there is another drug, another very important drug, ceftriaxone. Another drug is your ceftriaxone. Ceftriaxone have which functionality? So only one change is there in ceftriaxone as compared to cefotaxime. Here whole this acetoxy groups is substituted with only methyl group. Then whole structure remains as such, same thiazole, same amine group, and same carbon is bonded with double bond to nitrogen and then methoxy group. So this is the structure of cefotaxime. Now we have another very important drug, ceftriaxone, third one. Ceftriaxone. Ceftriaxone. So what are the changes in ceftriaxone? So this portion, R1 portion remain as such, the changes takes place at this R2 position. So what are the changes? So in ceftriaxone, as the name indicate tri, means somehow three peculiar things is there. So what are those three number peculiar thing? First is your CH2 and S, sulfur is there. Now this sulfur is directly linked to 6-membered nitrogen containing nucleus. This drug have suffix on. On means ketone. So here is your first ketone, and here oxygen and nitrogen, and on this position again there is a methyl group. You have to remember this thing only. What? Safe tri. Tri means what? 3 nitrogen. So 3 nitrogen containing 6-membered nucleus is there, and on this 3 nitrogen containing 6-membered nucleus there is one on, ketone. So this is your ketone and methyl. So this is the structure of safe trihexone. Now there is another drug which is ceftazidime. Ceftazidime. So what are the changes in ceftazidime as compared to your safe trihexone? So here one changes. This methyl group is removed from this position, and again there is a carbon with dimethyl and one carboxylic group. This is the first change. And in ceftazidime, this whole ring disappear, and this CS2 ring, CS2 methylene group is directly linked to nitrogen, and nitrogen is a part of this 6-membered nucleus. So this 6-membered nucleus is known by the name what? Pyridine. This is what? Pyridine. So this is the structure of ceftazidime. This is what? Ceftazidime. So here these are the some important cephalosporin of 3rd generation. Now we will move on to the next 4th generation cephalosporin. So now we will move on to the next 4th generation. So this is your 4th generation cephalosporin. So what are 4th generation cephalosporin? So 4th generation cephalosporin possesses a quaternary nitrogen. Their characteristic feature is what? They possess as a quaternary nitrogen, and along with this they have improved activity against Pseudomonas aeruginosa. Pseudomonas aeruginosa. So this is the first cephalosporin which show quite we can say quite improved activity against your Pseudomonas aeruginosa. This 4th generation cephalosporin clearly shows some improved activity against the Pseudomonas aeruginosa. So what are the example? So in this class only single example, single drug, single compound is there, which is cefepime. So what is the structure? How this cefepime looks like? So what is the structure of this drug? So again as usual, as we have seen in the previous third generation cephalosporin, here comes your what? Carbon, and on this carbon there is nitrogen, and on this nitrogen there is methoxy group. So this remain as such, and this carbon is again directly linked with what? Thiazole. So this structure is also same here. This is your thiazole, and on this thiazole what is there? There is an amine group. So amine group remain as such. Now what is substituted at position third position contain what functional group? So here again CS2 group is there, and as we have discussed, quaternary nitrogen means here the nitrogen is present in pentacyclic nucleus, and this nitrogen again have a methyl group, so it becomes nitrogen acquire positive charge, and this pentacyclic nucleus is what? This is the saturated ring of pyrrole. So pyrrolidine, this is your pyrrolidine. What? Pyrrolidine, saturated derivative of pyrrole. We have already covered all this heterocyclic nucleus in our first lecture of this your medicinal chemistry. We have already covered. So this is your fourth generation cephalosporin. Now we will move on to the next class. There is another class, that is fifth generation cephalosporin. First of all, you have to memorize that they are active against both gram positive and gram negative, means they have expanded spectrum of activity against both gram positive and gram negative. They are active against both, means they have higher activity against both gram positive and gram negative bacteria. Now this fifth generation cephalosporin shows in vitro activity against methicillin resistant staphylococcus and Haemophilus influenza and Pseudomonas aeruginosa. So this is the fifth generation cephalosporin which shows highest activity against Pseudomonas aeruginosa. But this activity is shown in vitro. You have to memorize this. There is no proof till now that whether they have activity in vivo against Pseudomonas aeruginosa or not. So in vitro they shows highest and improved activity against Pseudomonas aeruginosa, and they are generally used in the treatment of hospital and community acquired pneumonia. So this fifth generation cephalosporin is generally used in the treatment of severe cases of pneumonia. So what are the example? So have a look at the example. This fifth generation cephalosporin include ceftobiprole. The best example is ceftobiprole. Now here the suffix come biprole. Bi means two, prole means it looks like pyrrole. So biprole means two pyrrole rings are there. So where those two pyrrole rings, and what is the structure of this drug? So have a look at the structure. First, again same, the acylation. So this acyl carbon, the acyl amino group have this carbon here, and this carbon is linked with nitrogen, and this nitrogen is linked with oxygen. Now again here same ring as we have discussed earlier, but this ring have two nitrogen. So here your first nitrogen and one more nitrogen is there at this position, and both nitrogen is linked via sulfur, and here double bond is there, and on this position here again the same group, amine group is there. So sulfur containing two nitrogen pentacyclic ring. Now this is the changes at your R1 position, and what are the changes at R2? So the following changes are there. Here CH bond is linked with double bond to your first pyrrole nucleus, is the name of this drug, bipyrrole. So this is your first pyrrole, and on this pyrrole there is a ketone functionality, and again on this first pyrrole ring there is again a second pyrrole, in this manner. It's not actually pyrrole, because pyrrole have unsaturation, but here both the rings are saturated, so it's not exactly pyrrole. pyrrolidine. So bipyrrole means 2 pyrrolidine nucleus is present here. So this is all about your cephalosporins, beta lactam antibiotics. I hope you understand.